and 256 divided by 2, you get 128. So you have the negative 128 plus 128 times root of 3 and times I. Any question? So from this example, you can see the fourth power of the negative 2 plus 2 times root of 3 times I is equal to this negative 128 plus 128 times root of 3 times I. Let me write this result here. We have this result, negative 2 plus 2 times root of 3 times I raised to 4 equal to negative 128 plus 128 times root of 3 times I. And we know how we define the root of a number. Say if we have the a squared equal to b, then a is equal to plus minus the root of b, right? Or just say a is a square root of b. And if we have the a to fourth equal to b, then a is a fourth root of b. So right now, this negative 2 plus 2 times root of 3 times I is a fourth root of this negative 128 plus 128 times square root of 3 times I. So this is the 1/4 root of this complex number. So now, generally, if we have the z, which is a complex number, we use this blackboard bold C for the set of the complex numbers. So the z belongs to this set. That means z is a complex number. And we have another complex number, a plus bi. If the a plus bi raised to n equal to z, then we just see this a plus bi is an nth root of complex number z. So now, let me write this z in the trigonometric form. So z is equal to r times cosine theta plus I times sine theta. And also write this a plus bi in the trigonometric form. So it's equal to s times cosine alpha plus I times sine alpha. Then from the z equal to the nth power of a plus bi, because we have the a plus bi is the nth root of z, right? So the nth power of the a plus bi is equal to z. Then from this equation, we have the r times cosine theta plus I times sine theta equal to the nth power of s times cosine alpha plus I times sine alpha. Okay. Now, by using the de Moivre theorem on the right side, then we get r times cosine theta plus I times sine theta equal to nth power of s times cosine of the n alpha plus I times sine of n alpha. Now, let's first take the moduli of the both sides. So on the left side, the moduli of this complex number, the modulus of this complex number, I times sine theta, and the modulus of this complex number on the left side is equal to the square root of the square of this real part plus the square of this imaginary part. So this guy is equal to the r square times cosine square theta plus sine square theta. And by the fundamental theorem, by the fundamental identity, we know this is equal to 1. So this is equal to square root of r square, which is equal to r, because r is positive. Right. Now let's look at the right side. Let's try to find the modulus of this right side. Let's move to the next page. So the modulus of this right side is equal to the square root of the square of s to nth times cosine n alpha plus s to nth times sine of the n alpha. So this is equal to s to 2n times cosine square of n alpha plus s to 2n times sine square of n alpha. Now you factor out this s to n, s to 2n, you have the s to 2n times cosine square of n alpha plus sine square of n alpha. Okay. Still by the fundamental identity, this is equal to 1, so we have the square root of s to 2n. And this same as the s to nth and then square and then take the square root. And we know this is equal to s to nth, okay, because s to nth is positive. So now, let's compare this with the result we got here. This is the modulus on the left side, and then s to nth is modulus on the right side, because we know they are just the same complex numbers. So they should have the same moduli. Then we know r is equal to s to nth. Any question? Right? Actually, I just take the moduli of the both sides. They should have the same moduli. And then from here, you can find the s. The modulus of the nth root of this complex number z is equal to the nth root of r. Because here, the s is positive, right? We just take the positive nth root of this r. Now, let's compare the real part and the imaginary part of this, okay, both sides of this equation. So the real part on the left side is the r times cosine theta, And the real part of the right side is the s to nth times cosine of the n alpha. So by comparing the real parts of the both sides, we have the r times cosine theta equal to s to nth times cosine n alpha. And we know s to nth is equal to r, so we can cancel these two r's from the both sides. This just implies you have the cosine theta equal to cosine of n alpha.